How to model a vessel from a drawing? What is a transition opening by head? See this step-by-step advanced tutorial from our special exercise series. We are going to model this vertical vessel on 4 legs with a bolted cover at the top, the nozzle located over it with a setting. Then we have 2 conical transitions. And the most important part, and the one that gives the title to this chapter, the transition opening, that is changing our reference. I'm also going to explain what is the difference between this and a nozzle. Just get started. Here you have the drawings and the table of nozzles so that you can do it from home. For better understanding, here are some pictures of the 3D that you can screenshot too. Let's begin now. We go to the menu File, New, Pressure Vessel by default, press OK. Then we are going to select the closest template to our final design, which is this one in this case. We select it and then we click on Next. This example is done with Ian, so let's look for it. Ian local load method, Ian flanges, Ian pipe standards. Then we click on Next. This is not so important because this is an exercise for modeling, but we are going to fill them anyway. So we have 0.2, 155, 0.6 for the fluid liquid specific gravity, and 3 millimeters of corrosion. With internal conditions input, we just click on Next. Next again, Next, and we stop here in the Geometry tab. Our initial diameter is okay, it's 1,400, but the distance between tender lines is lower, it's also 1,400, and that's going to be it. We just click on Next, and Next again. By default, we have Ian materials assigned. We're happy with that, and we just click on Next. Now, let's work on the upper half. We click on the shell, insert a copy after, because we're moving to the top. We're going to insert a shell with a length of 200 and an external diameter of 1000. Then we click on Next. Let's introduce a conical transition between them after cone, a length of 200. We have no knuckle here, so we just have to click on Next. Let's do the same with the lower part. We are going to double click on the elliptic ahead, replace it by a shell with a length of 500 and an external diameter of 457. And we click on Next. Now, let's introduce the conical transition between them. Insert after cone. The length is going to be 600. And here we have a knuckle at the large base and small base. With that, we are okay. Now, let's input the head at the bottom. Before this time, an elliptic ahead with an axis ratio of 2:1, and that's going to be it. Now, here comes the dilemma of doing the lower part as a nozzle or as a transition opening. Well, as a nozzle, it's quite easy. You just click on Insert, Nozzle. Well, let's call it N1, nominal diameter of 200, location minus 150, and we add an standard flange, welding neck, 200, nozzle flange, apply, and that's it. Let's just apply a piping material according to CSEN and a flat material going to CS. And that's it. That would be the way to do it. But here we are going to do a transition opening. That will change my reference line. Let's just erase this nozzle. We click on the elliptic ahead. We right click, insert a copy before selection. We select a shell. This one is going to be 219. The length is going to be 400. And the material is going to be the one of a nozzle. So nozzle neck, Ian, apply. Now you see that my reference line has just done here. And if I double click, first time I have the properties as a geometry element, and if I click OK, I see its properties as a nozzle. And you can see the new tag xt0 and the designation as transition opening. Here I can control, for example, the size of the pad. Then I click on OK. Now, how do I add the flange? Well, I select it and I say insert a copy before selection, and I select a standard flange. It's the same one as before, so I just select OK, and here I have. Now let's position the legs. We double click on the legs. Let's change the design code. The locative method is OK. The standard for the base plate is going to be AP vessel. Our norm is EN. The type is H. We have 4 legs. They are 1 meter 800 tall. The orientation of the first is 30 degrees, and our profile is HB 100. The disposition is okay. Then we just have to place them in vertically. So we have to change L, the distance between the top of the head and the reference line. And that's going to be it. We just have to define our materials. So material here, it's a support. Going to EN, the ball material. Select bolting. And for the base plate, we do the same. We select EN, support, and that's it. Now our legs are correctly positioned. Now let's model our first nozzle located at the top of the vessel with an offset to the left side. We go to the menu Insert, Nozzle. We give it a name. It's going to be O4. We are using DN 150. Location is at the top. I just put something big. It is offset, as I mentioned before, and our left. Then we add a flange. Welding neck, 150. He detected it. Now it's an EN material for a nozzle flange, and we got a rating. Click on OK. Now we assign the rest of materials. EN for a nozzle neck, and EN for a shell. And that's it. We have our nozzle. Now, there's one thing missing here. I told you before that it was setting, so let's add those. We add the external projection of 200 and the internal portion of half a meter, and then we click OK, and now it appears. Now the second nozzle is easier. I'm just going to go through it quickly. Nozzle takes O2. I add my dynameter, my location from the tangent line, orientation, and it's slightly inclined 15 degrees. It has a projection of 200. Now I add my standard flange. And the rest of materials. We are going the goose nozzle now. We know it has the same diameter as O4, so we are going to copy it, edit, add a copy. We change the name. Then the location, of course. Now offset. Same orientation. It is inclined to be perpendicular to the cone. The extension is different. There's no internal, and it's a goose, so we select the goose check box and we add the dimensions. And that's it. We just click OK and we have our goose nozzle. Now let's insert the last two nozzles. And we do a copy of this one. With that, we run calculation, execute, calculate strength. Now we can see that our opening at the bottom appears in two ways. It appears as a shell, and it also appears as an isolated opening called XT0. That's why when the opening is comparatively big regarding the head, this method is safer. Not only that, it can be more practical. It allows you to continue your vessel farther from it, as it is a geometry element instead of a dead-end nozzle. Just notice that the reference line starts with it. What happens if you model it as a nozzle instead? Wanna compare? Check out the next video. Thanks very much for watching.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.